I believe this is the worst LED light show you have ever seen. Okay, let's back to business. I just purchased a new UniFi switch. Pro-Max switches belong to the new product line from Ubiquiti. There's an interesting cloud icon which replaced the traditional UniFi icon. Inside the box, there's nothing special, the traditional accessories for UniFi switches. This is the comparison among 3 UniFi switches, the 24-port Pro, the 48-port Standard, Non-Pro, and this Pro Max. They are very similar from outside if they are not powered on yet. This is the rear view. You can see the Pro switch and this Pro Max switch. They have the special part for UniFi redundant power system. From the side view, you can see the 24-port Pro and the 48-port Non-Pro has the same depth, but this Pro Max is about 2 inches deeper. I have been waiting for the release of a UniFi 2.5 gigabit switch for a long time. Let me explain you why I need such a switch. Before the Pro Max switch, Ubiquiti already had multiple switches which support 2.5 gigabit. For example, Enterprise PoE switch, Enterprise XG. The third one is today's hero, the Pro Max. The problem for the first 2 switches is, for example, for the Enterprise PoE, yes, it has 12 2.5 gigabit ports, but they are also PoE ports. I don't really need PoE for my use case. And for the Enterprise XG switch, all the 24 ports are 10 gigabits. Of course, they support 2.5 gigabit, but again, for my use case, I don't really need 10 gigabit. For the PoE Max, it has 16 2.5 gigabits ports, enough for my home network. It checks all the boxes. That's why I was super excited when I knew Ubiquiti released such a switch. It could have been a perfect switch for me, but it has a problem. In the left side, you can see the traditional RJ45 port, which we are familiar with. It has link LED light in the left and the status LED in the right. It will show you the current link speed, whether currently is transmitting data or not. Simple and useful, and also cheap. But for some reason, Ubiquiti thinks it's a good idea to completely throw it away and introduce a LED light which can change color. I am the type of person who is going to turn off LED lights the first thing after we receive a computer device. I really don't want to waste my time explaining how Ubiquiti's inventive LED lights, how they work. If you are interested, you can check those YouTube videos which show you how excellent Ubiquiti's idea is. Some people may say, what a big deal. If you don't like it, simply turn it off. For example, here you can change the so-called ether lighting to speed so that you can somehow get back to the old traditional way, right? But in real world, because of the buggy implementation, it doesn't work completely. For example, here you can see for the 100 gigabit, I expect to see yellow color, right? And if you go to the port manager, you can see these 6 ports. They are currently showing FE speed, which is 100 gigabit, because my mini PC is in off mode. All the 6 ports, they are in the power saving mode. So then at this moment on the switch, I expect to see yellow color, right? But this is what I see. All the 6 ports, they are showing no LED light at all, just like they are not connected. Basically, it's giving me the wrong information. Okay, enough about the pointless gimmick, the so-called ether lighting. Let's talk about the topic I'm more interested, performance testing. The second half of the video is about throughput testing for this switch. If you just look at the specification from Ubiquiti, you can see the two numbers here. For non-blocking throughput, Ubiquiti gives you 112. But where this number come from? In fact, it's a simple calculation of all the 52 ports. So 32 gigabit, 16 2.5 gigabit, and that for 10 gigabit. So the total is exactly 112. Because it's two directions, so the switching capacity is 224, right? These are just numbers on paper. But I am more interested in my environment, in extreme situation, how this switch will behave. I am going to do the testing in my lab environment. I'm going to use three switches. The Pro-Max-48 switch, it has four 10 gigabit SFP plus ports, and the Pro aggregation, it has four SFP28 port. Each of them has 25 gigabits. And the Enterprise 24X3 switch, it has two SFP28 ports. I will link these three switches using link aggregation. So from Pro Max to Pro aggregation, in total is 40 gigabits. From Pro aggregation to Enterprise X3, it's 50 gigabits. Then I will run 4 Linux virtual machines on 4 separate physical rack mount servers. In fact, each one of them has enough 10 gigabits ports already, but I just want to use 4 separate machines to avoid the potential resource conflicts. Then in the end, because I want to test the Pro Max switch, it has 16 2.5 gigabit ports. So I'm going to use 16 clients, each one connected to one 2.5 gigabit port. I have 4 groups of clients. The first group from a mini PC running EXXI. The second one, similar machine running EXXI. The third group for Windows machines. Each one of them is running Windows 11 Pro. And I have 4 Mac machines. You can see it's a very busy testing environment. I don't expect this testing to be very accurate, very scientific. That's not my goal. My goal is just to simulate an extreme situation in my lab environment. The total throughput I get will be lower than Ubiquiti's theoretic number, right? But that's not the point. I just want to see how it works in my environment. These are the part situation for the 3 UniFi switches. So the USW-Max switch, you can see the 4 SFP plus ports, they are aggregated, and all the 16 2.5 gigabit ports, they are occupied. They are all showing the light blue color, which is 2.5 gigabit. And then for the Pro aggregation switch, the 2 SFP28 ports, they are aggregated. And for the Enterprise X3 switch, these 2 ports are aggregated, and the 4 EXSI IPERF3 servers, they are connecting in 10 gigabits. You can tell from the dark blue color, right? These are the 16 clients running at the same time. Let me start from the upper side. The first row is 4 Linux virtual machines from a EXSI server, and the second row is from another EXSI server for Linux virtual machines. The third row for Windows machines, and the fourth row is for Macs. By the way, for the Windows machines, I'm using remote desktop. For the Mac machines, I'm using screen share to connect to them. You may know this way of connection will also use some network resources, right? So what I'm doing is I connect to Windows and Mac using Wi-Fi connection. And then in the network connection settings, I already made sure in my testing the 2.5 gigabit interface will be used instead of the Wi-Fi. Basically, however I share the screen, it won't impact the network testing results. Another thing I want to mention is you may notice for the Windows machines, they are also showing the Debian icon. The reason is iPerf3, the tool I'm going to use for the network throughput testing. On Windows, it doesn't support bi-direction, the two-direction testing at the same time. So I simply enabled the Linux subsystem under Windows. I'm running iPerf3 in the Debian subsystem inside Windows 11. After talking about the 16 clients machines, let's take a look at the 4 servers which will be running iPerf3 servers. In each one of them, I'm going to run 4 iPerf3 servers. Each one will be listening to 8 part. So in total, I have 16 iPerf3 servers. They are all running in bi-direction, both receiving and sending. And just to get a perception about the network throughput, I'm also running the activity monitor so we can see the speed right away. Okay, so now I'm ready to start the testing. Before kicking off 16 parallel testings, let me just test one part first. So in the iPerf3 server side, let me run a server. Then in one of the client, which is from a mini PC EXSI server, let me run the upload throughput testing first. Okay, 2.3635, very good speed. Then change direction, this time it's download. Okay, similar good speed, right? So just by looking at one direction, the result is perfectly fine. But let me run the bi-direction testing. So you can see the download and upload speed are very uneven. The download speed is much lower. So this is a very normal situation if you do the testing using a weak hardware. Keep in mind, this is on a Linux virtual machine running on a mini PC EXSI server. So later in much better hardware, for example, Mac machines, you won't see this kind of situation. Okay, so let me kick off 16 parallel testing. As you can see in the server side, I started 16 iPerf3 servers already. Then from client side, let me kick off 16 parallel iPerf3 clients running bi-direction throughput testings. Okay, for the first row, the 4 clients are running. And if we check the server side, you can see from the activity monitor, from server perspective, for receiving speed, which is client's upload speed, is close to 8 gigabits, but for client's download or server's sending, it's very slow. It's just 2 or 3 gigabits. Then let me move on to the second server. Okay, the 4 clients are running. Then you can see from server side, the blue line is only about 5 gigabit and the red line is even worse than the first mini PC. Keep in mind, the first 2 servers, they are both based on very weak hardware already, and the iPerf3 clients are running on Linux virtual machines. Basically, these 2 bad results are not unexpected at all. Then let me move on to the more reasonable modern Windows and Mac hardwares. Let's see what's the result there. Windows machines. You can see it has similar issues as the previous 2 groups. For upload, the speed is pretty good, but for download, it's very bad. And we can tell from the server side activity monitor, right? The Windows result is not expected at all, but let me revisit it shortly. Move on to the very last group, the 4 Mac machines. all the Mac machines iPerf3 clients are running, or the 4 Mac machines do not have the similar issue as previous 3 groups. For the Mac machines, the download and upload speeds, they do not have a pattern where one is good, one is bad. No. If we check the server side, you can see the red line and the blue lines are at the same level. Right? So now all the 16 clients are running already. Let me summarize what I have observed. So for the 4 Mac machines, the results are very expected and nothing special. They are good. And for the 2 mini PC EXSI servers, the first 2 groups, the results are bad, but I can't think of a reason. One important factor for the bad result in the 2 mini PC EXSI clients is the weak hardware, especially the weak CPU. You can see the 2 EXSI monitors side by side. For both of them, the CPU is the bottleneck. Of course, the weak hardware is one of the major factors for the bad speed, right? But it still cannot explain why the download speed was so bad, and especially why in Windows, all the 4 Windows machines, they all have modern hardwares, why they have similar issues as the weak hardware, right? Remember I mentioned for the 4 Windows machines, just to use the bidirection option for iPerf3, I run the iPerf client under the Linux subsystem instead of natively under Windows. Maybe that's related to our bad result. Because I cannot explain the result for the 4 Windows machines, I decide to do one round of extra testing. So on the screen, in the left side, you see the iPerf3 servers. Instead of running 4 parallel servers, I'm running 8. In the right side, you can see the 4 Windows machines. Here I'm not running Linux subsystems. Instead, I'm running the iPerf3 natively under Windows. Because it doesn't support bidirection, I need 2 separate sessions, one for upload, the other one for download. Let me start with the first Windows machine. In the upper session, let me run upload. Yeah, pretty good result. In the lower session, let me run download. Okay, this time the result is much better than the Linux subsystem result, right? So you can see the red line and the blue line, they are very similar already. Before we draw a conclusion, let me move on to the second machine. Okay, not too bad. The third machine. Okay, now all the 8 sessions, they are running in parallel, and you can see the total throughput is improved than the Linux subsystem. Of course, the result is not as good as Mac. One of the reasons is the 4th Windows is a very tiny mini PC. It has a very weak CPU. So now the CPU is becoming the bottleneck. That's why the result is not as good as the others, which impact the total throughput. Under Debian Linux, the iPerf3 implementation may have some issue, so that when you do the bidirection testing, it will screw your results. Now the 16 parallel bidirection testings are already running for a long time. This is the UniFi network controller for this Max-48 switch display. You can see the temperature is not very bad, 55 Celsius, and the fan level is 25. Memory usage is nothing. So basically, even for such extreme load, the switch still behaves very well. Because of the success for Windows machines, I decided to retest the mini PC EXSI Linux virtual machines. So on the screen, in the left side, you can see 4 Linux virtual machines. Each one of them is running 2 terminals, one for download, one for upload. And in the right side, you can see EXSI server. It's running 8 sessions for iPerf3 servers, 4 of them for download, 4 of them for upload. So you can see now I'm running download only. Of course, the total throughput is not ideal, just a little bit over 6 gigabits. At least for me, that's acceptable for this weak hardware. But if I run the upload at the same time, as you can see, the total upload is close to 8 gigabit, but download is even below 2 gigabit. It's almost the same result as our first round of testing when I run the bi-direction, right? So my conclusion for the Linux virtual machine running on weak hardware is 2 factors contribute to the bad result. One is the weak hardware, the CPU. The second thing is I still suspect the implementation of iPerf3 make the different behaviors for download and upload. It seems the software is focusing too much on the upload when the CPU is not powerful enough. Another thing is from the throughput graphic, you can also see the download and upload speed. They seem to impact each other. I'm not sure whether the network chip itself has problem within the mini PC. If you have the answer, please let me know in the comments. You may wonder for a UniFi switch video why I spend most of time on my own throughput testing. The reason is I purchased this switch for its 2.5 gigabit ports, and a factor impacting the 2.5 gigabit network is the computer itself. If you use a computer with gigabit port, the computer may not be very performant and you may not care at all. But if you have a computer with 10 gigabit port, 99% of chance it's a powerful computer and you care about the throughput, right? But when it comes to 2.5 gigabit port, the situation is much more complicated. In many cases, you use a mini PC with multiple 2.5 gigabit ports. In that typical situation, the computer's performance will be a much bigger factor for your final network throughput result. That's why I really want to see how it works in real world. Okay, thanks for watching.